Hello guys, welcome to Inside Electronics. So in today's episode, I'm going to show you guys something that I built myself back in 2009 when I was a college student. You know, when I was when I joined my college as a first year electronics student, right after a month or so, an exhibition came, a tech fest came, and it was mandatory that every class has to make something. And because we are electronics students, we were supposed to make something that is electronically themed. And after a lot of discussion in the class and things like that, and we finally decided to move on with the theme of communication. Basically anything communication. We are electronic students. We know how electronic communication works. So and the actually this was a part of it. Actually, our main idea was to build a tiny scale down model of how the entire mobile communication, the mobile network, the 3G, 4G, 2G, not 4G, the 2G, 3G mobile network works. And we are provided with an entire room provided with an entire empty room, and we can do whatever we want inside that room to make things come to life. So we actually used around 75% of the entire room to actually design every, like the base station. We actually fabricated the mobile towers using iron and welding machines and things like that. And I'm proud to say that I did all the electrical works for that entire thing. It was actually a really big room, and 75% of the entire room is covered with our main project, and it all needs power. Every base station and everything. We actually used a lot of LEDs and different lights and things like that to make it look, somewhat uh, realistic. And I did the entire wiring of that thing. I'm so proud to say that. And this also, not just this one, like there is a couple of electronic items actually, and that includes this wireless infrared wireless music transmitters. And I made this by my hand. The transmitter and receiver assembly, I assembled this at night. I still remember it was late at night. I was making this around 2 a.m. at night when I doing the final soldering and testing of these things. I still remember making this one, just like it is happening right now. So there was actually some other projects also, like a mobile detector, a mobile jammer, and things. I'm sure that I can find the circuit somewhere here in my attic. And by the way, this thing, just like in my previous video, I found this one in my attic also. So let me show you that this thing has two units. Basically, any communication has two units. The transmitter, as you can see here, it uses two LEDs, and this one is to indicate the modulation, and this is the power, and something is coming out. Oh, okay, so this a diode exposed, possibly for polarity protection. And on the other side we got a receiver which has two wires. These are for the speaker and this is for the power, and it uses a phototransistor. So basically we use this to explain how wireless communication works, especially how optical wireless communication works. And also we use this exact same module for demonstrating how the fiber optic communication works, because all it really needs is a optical fiber in between and connected to the phototransistor over here. This is a phototransistor. This is, I think, an 14F, I think 14F, L14F or something like that. I will check the datasheet later. And basically when both of these things are powered, and when you keep this thing like that, this thing transmits the audio signal to here, and this thing actually receives it. So that makes the wireless portion of it possible. And by keeping them like that, you're basically, nothing is being transmit. There is a lot of things that's being transmitted from here, but it is not receiving at this point because there is no direct path between it. So we used an optical fiber like that, from there to here, and the infrared beam passes through the fiber back to here, and that's how we explained the fiber optic communication. And all it differs is that we have to additionally explain how the fiber optic works in that section. So we use this thing for multiple purpose, and I will actually show you what's inside both of them. So down in the description you can find all the datasheet for any of the item that I'm using inside both of these. And also if any other info, like I can provide you the circuit diagram, and that also will be in the description. You can find the link to the, it's basically a picture, and I will link the picture, and you can find the links in the description. Let me just take this out, and also let me take that one out. And I'm using a case that is actually designed for, you can see that the case, the entire metal case is a metal case right here, and the case is actually designed for a power pack. You know, back in the days there were no SMPS, there is no Chinese SMPS like power supply. We used good old transformer power supplies for everything, and this thing is designed for such a rectifier pack. And let me unscrew it really fast. Okay, so actually this thing, I remember this has a melody generator IC inside. I will show you the datasheet in a moment. In the transmitter side, inside the transmitter, it has a built-in, a specialized chip inside that is creating the melody. So let me open the receiver side first. It is tight. Okay, that's the receiver side, and I'm going to open the transmitter side right now. That is the transmitter side. So as you can see, let me start from the, let me keep them side by side. Let me adjust the zoom a little bit to make you think, that will help a lot. Yeah, that will help. The lighting is somewhat okay, I think. So that is the transmitter section, and this was definitely I used a protection diode. This is probably 1N407, and I used a electrical tape to actually protect that, but it came off. The glue actually didn't hold up. And this was a specialized chip that I was talking about. It used a special chip called, and there is a reason why this is separated from the board. The chip is BT661 and 19L. You know, this is a special chip. The BT166 is actually a melody generator IC series. You know, there is the BT16. Let me show you the datasheet for this thing, and let me turn this flash off. And here is the datasheet for the BT66T IC. This is something, a switch is stuck over here, so I'm done with that. So this is BT66T, the 3-pin melody generator IC. This has a lot of features, as you can see over here. This has one-shot or level hold mode, plays melody at 1664 notes, built-in oscillator, and has memory built-in, and it can directly drive, this chip can directly drive a piezo generator, and this is the entire thing. That's what's inside this thing. You know, in an IC that only had 3 pin, this is such a complicated mechanism to be, you know, crammed inside. It has a tone generator, it has 3 different ROMs in it, the tempo generator, the control, the oscillator, the output circuit, everything built into a tiny little package, and it uses only VSS, VDD, and the output. That's it. The source, the drain, the positive, negative supply, and an output. And this is why the last 3 letters. Here you can see, let me turn the light on. It is BT1619L. So as you can see here, the BT6619L is that particular song, For Allies, and that song is very popular. I will actually play that once I'm done with this explanation. So that is the reason why the last lettering is important, because the IC will be the same, but the songs will be different based on what lettering you have on the last 3 digit. So, and this thing uses only 3.3 volts, and because of that reason we need to provide a 3.3 volt regulation down there. I will show you that, and I can show you that this thing runs around 3.5 volts, and the current consumption, the working current consumption, is really low. It is somewhere around 50 milliamps. That is it. Input current, it's only 50 milliamps. So this thing is really not consuming any power at all. and this can directly drive a piezo element. If you in right here in this circuit, I'm driving it to drive the LEDs, but if you connect a piezo element right at the output, it can directly drive it, no additional circuit needed. As you can see right here, it can operate in two modes, one shot and level hold. In one shot, once you given a press, it will play the melody until it stops, and that's it. If you want to hear that song again, you have to press it again. And in the level hold mode, you just need to keep holding the button, and only that for that long the sound will come. So I will link the datasheet down below, and now let's move on to this thing. So there is a reason why this thing is connected using an extension cable or something. Let me see if I can take that out. I can, but I'm not going to do that at the moment. Let me show you how the bottom side looks real quick, if I can do that. Okay, the reason why it is like that is because I'm living in a place where electronics shops are not that popular, and back in those days buying stuff from China like we used to do right now is not popular, and that's how the bottom side look like. I'm using a just prototyping board right here, and all the soldering is really bad, all the pins are poking out. I was not good at soldering back in those days, but anyways, yeah, the reason why is because where I live, there is not a lot of electronics shop, and we inquired in a couple of shops around us, and this particular IC, this particular tone generator IC was not available at any shops at all. So we finally got it from a shop that is like 60 or 70 kilometers away from our actual place. So we finally managed to find that, but still we just left it like that, because for any reason, if we are not able to find this particular IC, we can just directly feed the rest of the circuit using a regular audio signal, that is the blue wire over here. These red and green are the power, the blue is the output. So in case the IC was not available, we can actually use this blue wire to feed the audio in directly to the circuit. And the rest of the circuit is really simple. It uses, let me show you the circuit diagram. In fact, where is the circuit? And this is the circuit diagram. I'm going to turn the light off. This is what I did exactly over here. This circuit is an exact replica of this thing over here. So as you can see, it uses a 3.3 volt Zener across the UM66 for the protection, of course, and down there, that is the Zener diode over there, and it uses a capacitor to actually filter capacitor over there. That is providing the 3.3 volt for the IC, and the output goes directly to a BC547. It's a general purpose transistor. Let me turn the light flash off. It's a general purpose transistor. As we all know, every electronics person should have some BC547 in their parts bin, and there are couple of capacitors for filtering, and the SK100. I'm using the SK100 as the PNP version. That is that thing. And let me show you something really quick. If you take a look at the transistor, let me try to focus on that. You see, there's a lot of dust. Did you see that? It has a lot of oxidation going on, and that snow, the flake looking thing, is actually the oxidation that is happening on the top of that can. And that transistor right there, I'm currently using the SK100, the brother of SL100. So that is that final transistor, the power transistor that drives the two IR LEDs. So this is the entire, and that particular red LED is the one that is used for indication of modulation, the one that we just took, that one over there. So basically this is how the transmitter section looks like. Okay, so what is happening is that the audio signal comes out and it modulates the base of this transistor, and that in fact modulates the SK100 transistor. So what happens is that the varying voltage across this transistor will actually cause the LED to fluctuate, and the fluctuation will correspond to whatever signal that is coming at the input. In this case, it is this particular tone. So once that is transmitted, we need something to pick it up, and that is where the receiver circuit comes. So the receiver also, we are using very popular components, and except the fact that this thing, in the transmitter section, if this was the hardest component to find, in the receiver circuit this is the hardest component to find. I mean, let me show you the circuit diagram for this also. This actually is an L14F1 photo transistor, like that. If I can focus on that, that is a photo transistor. You can see the lens assembly on that, and it is actually a transistor, but the base is up here. It has both the collector and emitter, while outside the base is where the light goes inside. So what happens is that it picks up the infrared light that is coming through here. Basically we cannot see that, but the camera can. So this thing provides the light, and because there is two, there is enough power output. And when that comes to here, we are using two ICs. The first stage is a very common 741, the very common op amp, and that is used to adjust the gain of the photo transistor. Basically we are adjusting the sensitivity of this thing using this potentiometer and then front end assembly. And this is also acting as a preamplifier for the final audio stage, which is right here. And the audio stage is also very popular 386 IC, that is very popular, a simple audio amplifier all in one. So the receiver is very simple. We are actually receiving the signal through here, the photo transistor, and we are providing it as an input to the operational amplifier, and the gain is adjusted so that it makes an audible kind of, without clipping and everything. It provides the signal to the audio amplifier, and it amplifies and gives out the signal. Let me show you the circuit diagram real quick. I know the video is getting longer, but some things can only be explained like that. There is no other alternative ways. Okay, go away. Oops. Okay, there is. Okay, let me show you this way. Okay, now it's fine. So this is the receiver assembly, and we are using the photo transistor like that, and we have a 0.1 microfarad blocking capacitor because we don't need any DC component to get inside. We only need the varying signal, the AC signal, to go past this. So we don't for that purpose we're using this blocking capacitor, and that is provided as an input to this 741 IC over here, and that also has a blocking capacitor at the output, and that finally provides the audible signal to LM386 IC. So basically these two wires right here, these two, with this exposure real quick, these two wires right here are the speaker connections we just disconnected, and basically the rest of thing is real simple. That over there is adjust for the adjustment of volume, and I think that one is right there, and I will attach this photo also in the description. So enough of talking. I think the bottom also looks really bad at this moment. I'm using something as a spacer. Here I've used styrofoam as a spacer between the metallic case and the circuit board. Here I'm using plastic, bubble wrap for the separation. But anyways, this thing works. So let me arrange everything, and I will show you guys how this thing works. So I will be back in a moment. Okay, so guys, I now have completely wired up the thing, and as you can hear, let me bring the speaker. This is the speaker that I'm using right here. I'm bringing it close to the mic, and you can see the hum. That is because it is picking up. If I close the sensor, you can hear the hum is actually reduced, and that is because this IR sensor is picking up a lot of static from the nearby light sources, because I'm using a CFL lamp up there, and it also emits a little bit of UV infrared light, I think, and it's also picking up stray light from somewhere else. So that is the reason why it's making that hum. But here I'm running this receiver unit on a single 3.7 battery, and for a moment I'm just going to unplug it. I just want to show you guys something. So I disconnected the receiver, and I'm going to power the transmitter now. I'm using a 5-volt power supply for the transmitter, and when I plug this in and if I turn it on, just holding it, you cannot, the camera is not doing any justice up here, because the camera is not picking up the modulation. In fact, I think you can somewhat see a flickering on the LED, but I can clearly see that here with my eyes. The camera is not picking it up, but if I turn off the flash, the camera can actually see the infrared light. I'm certainly not seeing it, but the camera can see. But here also it is not picking up any modulation because the modulation is happening so fast. Right now it is actually generating the audio signal that is coming from here. And now I'm going to plug this receiver in. I'm going to pause and I'll be doing it. Okay guys, so I have connected the transmitter but turned it off. Let me remind you that because this thing was designed to be operated within a meter distant away, the sensitivity is adjusted so that this thing is much more sensitive. And because now the transmitter and receiver is in close proximity, even if I keep my hands in between, the IR rays that are leaked from the surroundings can still be picked up and it will still make this thing work. But keep it a meter away, this if you block the signal, it will not make any sound at all. But at the moment, even if I cut it, it will still make some sound. That is because of the leakage. So right now I'm going to turn the transmitter on, and you can clearly listen to the melody that is being created, and that is a really popular song that this chip has. So that's how this thing works. So, and I'm going to cover the transmitter with my hand like that. As I mentioned, because of the stray, this thing is right now being reflected from my shirt and getting back to here. That is the reason why it is still picking it up. So if I close this completely, it will still picking it up because of the close proximity. But if I release it, the reflector waves are making it picking it up available again. So that's how we used this thing to demonstrate wireless communication back in the college days. So I hope you guys got the idea, and if you want to build this, I can link all the photos down below. Let me just turn this off real quick, and you can actually power this thing up. You are using a single lithium-ion battery if you made this one, but this thing needs some more juice if you want to keep this thing away. And also you can hack it really simple. All you need to do is remove the IC and give the audio signal directly to this blue line, but keep in mind that you should keep the volume really low on the transmitting side. I mean, if you are using a mobile phone to give audio signal to here, you have to keep the volume low on the mobile phone, otherwise it will just flood the light and you are getting nonsense on this thing. That's one thing you have to keep in mind. And I'm sorry that this video got this long. It is all because I have to explain it. Like, I'm not doing it for money like all other channels do. They are just doing the DIY thing. I'm not doing it for money. I'm doing it because I just want to explain you guys how things work, and explaining things really take up time. And I got a lot of emails in my through my channel mail that I have to limit my video length to somewhat shorter, and I'm not doing it because as I mentioned, I'm not doing it for money. I'm not doing this for money. I'm doing it because I know how things work. I want to show you guys how things work, and that is the reason why I keep on explaining even the tiniest little details that you want to hear. So anyways, I think I explained everything. There is a protection diode. This thing also had a protection diode underneath. So yeah, thanks for watching. See you in my coming videos. Keep subscribing, keep supporting me. Thank you all.